Hello, everyone. So now that I've talked about McGritter and the concept of pipes, I want to talk about dplyr. I wouldn't be surprised if many students didn't install McGritter themselves, or at least not because I told them to, or for reasons other than I just said you need to do this assignment, you need to use McGritter. I would not be surprised if students were not using McGritter, but dplyr is a package that's pretty darn popular, far more popular than McGritter, and it also uses pipes. It basically borrowed the pipe operator from McGritter, and it's and so it's that means that discussion before you can use dplyr, which is a pretty popular package. This parenthetical is actually incorrect. That would mean so basically you're probably going to want to use this. Basically, the package dplyr is a way for you to start manipulating data sets, and one of the major uses of dplyr is subsetting. Choosing which columns of a data set you're going to use, which variables, and which rows you're going to use of a data set. So that's one major use of the package. But in addition to that, it's also applying transformations to data sets, getting summary statistics for data sets, and so on. So there's a lot of things that are done with dplyr. It's a pretty powerful package. You've already seen the subset function. We've talked about the subset function before, and the purpose of this function was to select the rows and columns of data sets we want to use, which you could also do via the square bracket notation. That's another way to select rows and columns, but all of these things tend to be clunky. Subset's not so clunky. Subset's a pretty good function. The thing, though, is subset, it's limited in its power, and additionally, it's essentially an interface to these square brackets, and thus it's requiring that you're working with data frames, whereas the functions that come with dplyr, they are not only working for data frames, they're working for a large number. Like, they could work with databases, SQL databases, which is where a lot of data tends to be stored, or they could be they could be they're also optimized functions. They're supposed to be working faster than the subset function. So we should probably be talking about how to use these dplyr functions, especially since you're probably going to encounter code that uses dplyr. So let's talk about some basic subsetting with dplyr. The thing about dplyr is that it provides a ton of functions that users can use to manipulate data sets. So there's basically a specific function for a specific job, and you need to chain those functions together using pipes. So the first two functions that we're going to talk about are select and filter. And these two functions together give you all the capabilities of the subset function that comes with base R. The select function is given a data frame as its first argument, and then further arguments, where those additional arguments to the select function are the columns that you want for your data frame. Whereas the filter function is how you're selecting rows. Again, the first argument to this function is a data frame, and then after that is some logical statement describing which columns, which rows you want to include in the final data set. So let's see some examples of how these functions are used. You're actually permitted a nice interface when working with a select for choosing columns. If you're familiar with the square brackets, you have to basically refer to columns in a very specific way. If you wanted to get all columns between the columns C and F, you couldn't do C:F. You would have to find the number that corresponds to column C and the number that corresponds to column F, and then do, let's say that was 2 to set 2, or let's see, 3 to 6. You would have to do 3:6 in order to be able to do that type of selection. Whereas here, you could, with the select function, you can basically do what you want to do, which is the name of the column on the left, name of the column on the right. and you'll get all columns in between. So let's first off, just as a reminder, here is what the iris data set looks like. This is the data set we're going to be working with. We're going to select all columns between petal length and petal width. So I run this line here with the subset function, and this is what subset comes up with. So this is how subset would be selecting rows and columns. Here's what dplyr does. First off, we need to load in the library dplyr. Then we take the iris data set. We're going to use the rows where the species is virginica and the petal length is greater than the mean petal length. And then we're going to select all columns between petal length and species. And this is the resulting data set. It's the same data set. The slice function in dplyr, that's another function that we need to work with. That's one issue that students potentially have when working with dplyr. There's a lot of functions to learn. So if we wanted to say, like, we just got a ton of rows here. We got 50 rows. What if we wanted just the first 10 rows of the resulting data set? Well, we could do those previous commands and then throw on the function slice 1 through 10. And that will get us the first 10 rows of the resulting matrix. So, okay. So let's say we wanted to rename columns. It turns out that the select function provides an easy interface for renaming columns. For example, we may not like the terms petal length and petal width because we may want to just call it length and width instead in the final data set, because there's not going to be a sepal length or a sepal width. So it just seems odd to specify that we're talking about the petals. So we're going to do iris. We're going to do the same filter statement, but now select, we're going to say length equals petal length and width equals petal width, and then species. And the result is a data frame where those columns have been renamed. And that's rather nice. If you basically wanted, let's suppose that we wanted to just have the same data set, but all we wanted to do was rename the columns. So let's suppose that this was our data set, and let's suppose we don't want to do any further subsetting with select or like be selecting specific columns, and all we want to do is rename columns. Well, there's a function called rename that we can use to just return the same data set but with different column names. Okay, so let's talk about potentially transforming our data and adding new columns. There is a function called mutate that can be used to form new columns. So this is similar to the transform function in base R. It allows for easily adding new variables to a data set using the existing variables. So yeah, we could, so the basic syntax is we could call the function mutate on a data frame and say our new column Z is going to be the result of some operation on the other columns X and Y. And that will return a new data frame that has the same columns as the original data frame, but with the additional column Z. So let's see an example of this. We're going to do the iris data set, select all columns between petal length and species. We're going to filter it out and say use only the rows where the species is versicolor. And then we're going to add a new column called difference, which will be the petal length minus the petal width, and a new column called ratio, which will be the petal length divided by the petal width. So if we run that line, okay, we're going to have that line. And also for the last function in this chain, that's going to be the head function so that we would get only the first few rows. All right, so the result is a data frame where we've got petal length, petal width, species. Those were the original columns. But now we've got two additional columns, difference and ratio, that correspond to the transformation that we did. Let's see some additional functions. dplyr has a ton of functions. We're not going to be able to get through all of these functions today. And in fact, if you're interested, there's an introduction here and a cheat sheet here that you can look at. These are also on the online notes if you want to see the links there. You can use those to kind of learn more about what's available to you in dplyr. There's a lot of stuff for a lot of actually fairly common operations. So I would strongly recommend you independently go off and learn more about this package. But let's say that we wanted to summarize some of the data in our data set, there is a summarize function where we can basically give this variables that correspond to calculations on our original data set. And what it will return is a vector containing those numerical summaries. So in this case, I've summarized the iris data set, getting the sepal mean, the sepal standard deviation, the first quartile, and the number of versicolor flowers in the data set. And this is the result. You can also, let's suppose that you wanted to select random rows from this data set. That is something that, as statisticians, we often want to do. We often want to select random rows from data sets. There's a couple functions that you could use. There's sample n and there's sample frac. Sample n says, get me 10 random rows from this data set, I believe without replacement. And sample frac means get 15% or approximately 15% of the data set, selecting from it randomly and without replacement. So if we wanted some random rows, this is what we end up with. So this could be handy for some procedures, such as bootstrapping. So as I mentioned earlier, dplyr can do a lot of things, and I would strongly recommend you independently go and learn some more about what dplyr can do and what it's capable of and all of the functions it has. Like, we haven't talked about joins. Joins are something that, if you're familiar with databases, that's a very common procedure. It's a way for you to combine information in different data sets. So that is something that's very important that we're not going to be talking about at all. But anyway, that's the conclusion of this, and I will see you in the next video where we're talking about the reshape package. So I'll see you there.